spontaneous combustion, it is a combustion, a combustible substance and oxygen are reacting to give heat and light energy, that's fine. But what is different in case of a spontaneous reaction combustion is that there is no apparent cause of the reaction. In simple words, no energy has been supplied or provided for the reaction to take place. The combustible substances they reach onto their ignition temperature on their own and hence they react. Getting it? No energy is being supplied for that reaction to take place. Are you getting the difference? When we are burning coal or
Yes,
when we are
ma'am.
burning LPG or CNG, okay, we are supplying energy using that ignition source, correct? Whereas in case of a spontaneous, we are not supplying any energy. There is no apparent cause of the reaction of the combustion. Okay, they spontaneous means what? On its own? Yes, it's very spontaneous on its own. So the combustion happens on its own, in simple words, without any ignition source. Is it clear? Is it clear? Yes or no?
Yes, ma'am.
I don't think so. It is clear. Is it clear? Example, we had white phosphorus. Yes, very
Yes.
important. White phosphorus. So it has a very low ignition temperature. Okay. Yesterday also we discussed. So what happens if it is kept in the air? It will gain the energy required for the reaction of white phosphorus and oxygen to take place, and the combustion will happen on its own. Clear? We will not need to supply that spark or any ignition source. Can
Yes,
you
ma'am.
give
I
me
get
one more
it.
example related to spontaneous action? One more
Example.
example. Yeah, one more example of a spontaneous reaction. Yes. Yes, Dua? Okay, no worries. Speak. Because we are short on time, so we will discuss it. White phosphorus is one example. Sodium, you must have learned in the metals and non-metals chapter that sodium and potassium, they're never kept in the open air like this. They are always kept in kerosene, right? Because if they're kept in
Oh,
the open air as such, what will happen is that they will form their oxides. Energy will be released in the formation of the oxides, and that energy will be enough for the reaction of for the combustion of sodium to take place. Yes, we are not giving any supply in simple words. So sodium, potassium, they can react, they can burst very, they can actually burst very much. So the energy release is huge. Therefore, it is not even kept in the open air. That is an example of a spontaneous combustion. Is it clear, Bachchan?
yes, ma'am.
Clear. One very important example. Very important. Forest fires. Have you heard of forest fires?
Yes, ma'am.
Yeah. So there, no one really goes and lights it up. The temperature rises on its own. Once the ignition temperature is reached, might be for some particle, that will start the combustion and that will actually spread. That is again a case of spontaneous combustion. Clear? One
Okay.
last very important point to be discussed. In case of coal mines, what happens? Unburned carbon, yesterday we discussed. Once that is saturated, once the you understand saturated? Full, okay?
Yes,
Once
yes.
the amount is maximum for the unsaturated carbons and they are there accumulating, what will happen after some time? They will have enough energy to react on their own with the oxygen. And that is actually very, very much high in energy. The energy release is very high, therefore it is very dangerous. Clear? So that is again a case of spontaneous combustion. Any problem in spontaneous combustion, Duha?
Ma'am, I have a question with the forest fire.
With the forest fire,
Ma'am,
yes, please go ahead.
yeah, so for the forest fire, actually, it's like in spontaneous combustion, it's also about very low ignition temperature, right?
Yeah, about very low ignition temperature because the point maximum, we can't say it like that because anything which is actually reacting very quickly without any need of energy, that might be because it has low ignition temperature. Yes, that
Okay.
might be one point. That might be one point. You getting it?
Okay, ma'am.
Is it clear, Bachchan?
Yes, ma'am.
Fine. You wanted to ask something regarding forest fire. What was it?
Yeah, ma'am, it was about the forest fire because you said that sometimes it gets fired on its own.
Yeah,
So
see,
I
the
just asked.
sparks,
Yeah.
what happens, the spark might be there on its own, right? That might produce enough energy for the combustion to take place. That is again a case of a spontaneous.
Okay, ma'am.
Is it clear now?
Yes, ma'am, I get
Yeah.
it.
So now coming on to the third type of combustion, that is explosion. What is it, Pache? What idea do you have?
Uh, it's when the combustion is it's when there's very rapid combustion and it's very huge, and the
It's
combustible
rapid,
substance is
it's
very big.
huge, and generally in closed spaces. Yes, can we say that? Because why is it so, vigorous? Because you understand vigorous very much on high on
Yes.
energy. Because there is an internal supply of oxygen. What is it? Internal
Ah, yeah. Internal supply of
supply
oxygen.
of
Yeah.
oxygen. That is why it causes this kind of combustion. Because there is internal supply of oxygen, there is no hindrance in the supply of oxygen. Therefore, the combustion will be very rapid, very vigorous. Yes. Now, when this is there,
Yes.
obviously huge amount of energy will be released along with heat and light energy. Heat, light, sound energy is also released. Yes.
Yes,
Any
ma'am.
confusion here?
No, ma'am. Ma'am,
No.
internal supply
Yeah.
of oxygen means like.
Yeah, we will discuss. See what happens. Let's say, bache, we have a firecracker like this. Please bear with my dear. Okay. Let's say we have a triangle. That's a firecracker. Now, sulfur and carbon are here. Now, these sulfur and carbon actually react with oxygen to have that firecracker part. Okay. I mean, these are the combustible materials in the firecrackers, right? Now, they will have to go undergo combustion. Obviously, they will have to react with the oxygen. Yes. And how will they react with the oxygen? We will give them some ignition source and they will actually react with the oxygen. The combustion will take place, right? Now,
Yes.
internal supply of oxygen, what do we mean by that? We actually, let's assume we have another compound here. Let's assume that is potassium chlorate. Let's assume, okay? Now, what will happen? As soon as we burn this, okay, we burn this, we burn the firecracker, yes? That means we supply the ignition energy. What will happen? Let's say we have this energy. This energy will actually help in this compound releasing oxygen atoms. Clear? In simple words, the potassium chlorate compound will decompose, and in that decomposition it will it will give these oxygen atoms. Now these oxygen atoms are here inside this firecracker only. We also have sulfur, we also have carbon, we also have the ignition source. What will happen? They'll be able to react very quickly with the oxygen present inside. You get it?
Yes, ma'am. I
So that is
understand
why,
now.
what do we mean by internal supply of oxygen? That is why it is very huge, that is why it is very rapid. Clear, bache?
Yes, ma'am.
So generally, explosion happens or explosive combustion happens when it is in a closed space. And there is what kind of supply of oxygen?
Internal supply of oxygen.
Internal. Is it clear?
Yes, ma'am. I get now.
Energy, light energy, and sound energy. Very important. And obviously, when the firecracker is burned, example, many gases as side products are formed. So they will obviously be there. Clear? Clear, bache? Any
Yes, ma'am.
confusion in this now?
No, ma'am.
Very good. Coming on to the next topic, that is, let's quickly discuss the matchstick part. Any idea regarding the history of matchsticks? Mm-hmm. Yes, bache.
No, ma'am.
Have you learned this? Have you studied this before?
No, ma'am.
Okay, so first I would want to discuss flame. At last, then we'll be able to discuss matchstick. Okay, very quickly. Just give me a minute. Yes. Do am I audible?
Yes, ma'am.
Yeah. So now coming on to the next topic, that is flame. What is flame, Bache? Yesterday we discussed something regarding this. What is it
Yes,
called as?
ma'am.
Yeah, flame.
Yeah.
So the light energy can be produced in two ways. Either it will be a flame or either it will glow. Okay. And
Yeah.
whenever flame is there, Bache, please understand one thing. Whenever flame is produced, I think I discussed this yesterday, but if not, please listen here. When is flame produced and when is glow produced? Please understand. Let's say we have this square. If you burn this, okay, if the mass or if the particles of this square will be able to vaporize, okay, vaporize, and then undergo combustion, then flame will be produced. Clear? So whenever vaporization takes place of a combustible substance, then that vaporization will lead to the production of a flame. Clear? And let's say we
Yes,
have
ma'am.
a triangle. If you burn this, it is not vaporizing. Due to some reason, it is not vaporizing. Therefore, what kind of light energy will it produce? It will produce the flame. Clear?
Yes, ma'am.
Yeah. Now, with the same concept, I want to apply on the flame of a candle. So, candle, what is it? This is wax. Yes, this is wax. Here we have a wick which is actually made up of cotton. Okay, yes, original cotton, pure cotton. Okay. Now, what happens? How does the burning take place here? This is wax. This is in the solid form. Can I say it like that? Yes.
Yes, ma'am.
Now, what happened? As soon as we light this up, okay, this cotton part is lighted up. Okay. Due to that heat energy, what will happen? The wax here will actually liquefy and eventually will turn to vapors. It will liquefy and then eventually it will turn to vapor. Are you getting it? As soon as it
Yes,
changes
ma'am.
to vapor, clearly it will undergo combustion. It has the heat energy. We have oxygen all around here. Yes, the vapors are here. They will actually, since it is vapor, they will move upside, upwards. Yes, not
Yes,
getting.
ma'am.
Should I explain again? Let's say we have a wax like this. Okay, these wax particles, obviously, they are at the top. They will be first be melted because of the heat energy here.
Yes,
Okay,
ma'am.
when they will be melted, they will then be changed to vapors because obviously we have the heat energy there. Getting. Once they have been
Yes, ma'am.
changed to vapors, clearly they will move towards upside like this. Yes,
Yeah, yes, ma'am.
they have the heat energy. We have oxygen all around it. Yes, the atmospheric oxygen. Don't you think these vapors, let's assume these are the wax vapors, they will actually react with oxygen to undergo combustion? Yes or no?
Yes, ma'am.
Any
Yeah.
confusion in this?
No, ma'am. I
No.
get it.
Now, yeah, now since the vapors were there, can I say that it will, since it's a combustion, it will produce flame? Because what? Why? Because vapors are there.
Yes, ma'am.
Clear? Any problem?
No, ma'am.
No. Now come to the flame. We need to learn about the flame. Okay. Let's say, bache, we have the wax. Okay. This is melting. I'm not drawing it again so as to have a clear diagram here. Okay. We have the wick here. Here. Now what will happen? Please try to understand it through the diagram. We have the candle flame, something like this. Please bear with my bad drawing. Okay. I just can't be better at it. Okay. Yeah. So something like this. Okay. What will happen? All the concept is related to the supply of oxygen. Yeah. Duhaa, you will tell me that this area will definitely have the, the most supply of oxygen. Yes,
Yes,
because
ma'am.
it's on the outer part. It's in direct
Yes.
contact with the oxygen. Correct.
Yes.
Now,
Yes.
this part will obviously have somewhat less supply.
Yes, ma'am. It has less
Okay.
supply than the outer layer.
Yeah. And this one will obviously have the least.
Yes.
Yes or no?
Yes, ma'am.
Yeah. So
I get
all
it,
the
ma'am.
concept that we are going to talk about, the different layers of a flame are actually because of this. The different layers of a flame are actually because of this. Here, let's say you are going by a cycle, your friend is going by a car, and your other friend is going by something else. Okay, obviously the time taken to reach, to reach a certain place will actually be dependent on the vehicle that you took. Here,
Yes,
in the
ma'am.
same way, this is the case. The parts of the flame are distinguished because of the supply of oxygen. Clear, Bachcha? Yes.
Yes, ma'am.
Now this part, which is the outermost part, the outermost zone. Okay, these are called as the different zones of a flame. Yes. So the outermost zone, Duha, the outermost zone, will it have less supply of oxygen or more supply of oxygen?
More supply of oxygen.
It will have a very good supply of oxygen. Yes. So now can you tell me, will complete combustion take place? Yes. You're able to
Yes.
understand? When complete combustion will take place, but don't you think blue flame will be there?
Yes, ma'am.
Yeah. If blue flame will be there and if complete combustion is taking place, will there be any unburned carbon particles? No.
No, ma'am.
No. Yesterday we discussed this unburned carbon particles. Yes.
Yes, ma'am.
What else will be there? Since, see, whenever complete combustion will take place, okay, because of no unburnt particles and all of that, it will not be visible. It will not be visible.
Visible.
Therefore, it is called as non-luminous zone. What is it called as?
Yeah, non-luminous zone.
Are you getting it? Any
Yes,
confusion in this?
ma'am.
Any confusion?
No, ma'am.
No. Now coming on
No.
to the next. Coming on to the next part, the layer within the this thing inside the outer zone. Clear? That is the middle zone. Middle zone. What will happen, bache? Incomplete supply of oxygen here.
Yes, ma'am.
What will happen because of that? Can you tell me?
It's incomplete combustion.
Incomplete combustion. What will happen because of that incomplete combustion?
The color will not be blue, it'll be yellow.
Very good.
Um,
Yes. Yellowish flame. And what will happen? One other point, very important.
um,
There would be some unburned carbon
it will
particles. Yes.
leave some carbon particles. Suit.
Yeah, it will have some unburned carbon particles. Clear, bache?
Yes, ma'am.
And so one thing in the luminous zone, bache, what will happen because it's a hydrocarbon. Yes, it's a hydrocarbon. Wax is what? Hydrocarbon. Are you able to recall it from the petroleum chapter? It's a
Yes,
hydrocarbon.
yes,
Yes.
ma'am.
So when it will burn, it's nothing but vaporized wax. It's nothing but vaporized hydrocarbons. When it will actually react with oxygen, don't you think it will produce carbon dioxide and water? So in the luminous zone, this is the
Yes,
reaction that
ma'am.
is taking place. In the luminous zone, this is
Yes,
the
ma'am.
reaction that is taking place. Clear? Come to the middle zone.
Yes, ma'am.
There will be some unburned carbon particles. Now, because of that unburned carbon particles, we actually have an activity in the NCRT. If you place a glass, okay, a glass, this very small is this thing, glass party slab, something like that, okay, in the middle layer, okay, we will get this black circle. Why do we get that black circle, bache? Clearly, that tells you about the unburned carbon particle.
Particles. Yes.
Fine. Is it clear?
Yes, ma'am.
Moving on to the next zone. What is it? The innermost zone. Yes, the inner zone. No supply of oxygen.
And
No
no
supply of
combustion
oxygen.
takes
No
place.
combustion.
Yeah.
Can you tell me any activity to have this thing clear?
What, ma'am?
Can you tell me any activity that through which we can prove this?
Um.
Yeah. See what will happen. Let's take this as the flame. Okay. This is the innermost zone. Yes. What will happen? This is actually discussed in the NCERT. That's why I'm discussing this. If you place a glass tube here, okay, in this zone, and we light and we have a matchstick here, yeah, a lighted matchstick to provide the heat energy. What will happen because these particles, these carbon particles, which these are in the vapor form, but they have not undergone combustion. Okay, they will actually come here and they will actually use this energy to undergo combustion because oxygen is there. Yes, here we have oxygen.
Yes, ma'am.
Any problem? Should I repeat this again?
Yes, ma'am.
Okay,
Little.
yeah. This is the flame. Please bear with me. Right. Okay, this is the innermost zone. Clear? There is no supply of oxygen. What will happen? Do you have your NCRT?
Yes, ma'am.
Yeah, please open that. We have an activity. I will show you there. Actually, better to have it in NCRT.
Yeah, ma'am. Yeah, I can see it.
Yeah, this part, Bachchan. Q.
Yes, ma'am. I
This
see.
part is the inner zone. This part is the inner zone. Now, inner zone has what? Carbon particles. Vaporized carbon particles,
Yeah.
but unburned carbon particles. Yes. Wax
Yes,
vapor,
ma'am.
unburned wax vapor. So that wax vapor will actually come here through this tube, and we have this source of energy. We have oxygen here. We have good supply of oxygen here. Therefore, that will undergo combustion. and then we can see the smell. We can see the vapors of carbon dioxide there. Did I repeat, Bachchan?
Yeah. Yes, ma'am. Now I get
Is
it.
it clear? Clear?
Yes, ma'am.
So now please go through this. We had this important point here. This thing. Bring a lighted matchstick near the other end of the glass tube. Okay. Do you see a flame caught at this end? Yes, we do see a flame. And why do we see a
Yes.
flame? Because see, we already had vaporized wax vapors. Yes. Those
Yes, ma'am.
vaporized wax vapors actually react with oxygen to undergo combustion. If so, what is that? What is it that produces a flame? It is the vaporized wax vapors that produce the flame. Clear, bache? Any
Yes, ma'am.
confusion here? Is it
No,
clear
ma'am, I
now?
get it.
Yeah. See,
Yes,
and
ma'am.
this part I was discussing about the unburned carbon particles in the middle zone. They actually keep it in the middle of it. So they actually get this black circular ring. That is because of the presence of unburned carbon particles. You will have it here. The
Ma'am, I have a
vapors.
question, ma'am.
Yeah, yeah.
Ma'am, what happens to the outer layer of the flame?
What happens to the outer layer of the flame? As in, Beta, can you please explain me this question? I'm not able
Like
to get.
when you like in example 4.11, we are bringing the candle to the glass, and it's showing that the middle layer
Black. Yeah,
is incomplete combustion. Yes, so
yeah.
happens to the outer layer.
We are actually, let's assume this is the flame, okay? Let's assume this is the flame. We will actually bring this glass piece like this. We will not bring it at the top, okay? That will actually hinder the supply
Oh,
of oxygen to this layer. We are bringing it at the middle zone only, clear? So that is
oh,
not
okay, ma'am.
hindering the supply of oxygen to the outermost layer. Therefore, that will be there as
Oh,
it is. I think this was the question.
yes, ma'am.
Okay, is that
Yes, ma'am.
answered?
Yes, ma'am.
Fine. Now, coming on to the next point. See. Now, this zone is what? The luminous zone, the outermost zone. Okay. When we will actually bring any metal rod here, iron, copper, whatever it will actually change the color because the temperature of this rod will be more. Why? What does it show? It shows that the temperature of the non-luminous zone is very, very, very high. Why is it high? Because it's very obvious complete combustion is taking place. Yes, so most amount of heat energy will be produced in that zone.
Yes, ma'am.
Clear?
I get it.
One important point here. The this this zone is, since it has a lot of heat energy, this zone can be utilized for melting some of the objects, example jewelry. So what happens if you actually direct this flame towards the jewelry? What will happen? The heat energy will be towards the jewelry and they will melt because this has very, 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 very high temperature. Clear?
Yes, ma'am. Yes,
Any
ma'am.
problem here? The goldsmith actually do
I
this.
know.
Now, a circular blackish ring is formed on the glass plate slide. It indicates the deposition of unburned carbon particles present in the luminous zone of the flame. The middle zone is also called as the luminous zone. Yeah, because we can see that because of the unburned carbon particles in the yellow flame. Fine. Now, hold a thin long
Yes, ma'am.
copper wire just inside the non-luminous zone. Non-luminous zone, the outermost. Just keep on imagining it, okay? Of flame for about 30 seconds. That the portion of the copper wire just outside the flame gets red hot. Why does it become red hot? Because the temperature of the copper rod again rises. Clear?
Yeah, it's very high.
Yeah.
Yes.
Does it indicate that the non-luminous zone of the flame has a high temperature? Yes, it indicates that.
Yes, ma'am. I get it, ma'am.
Because in fact, the part of the flame is the hottest part. Clear? See this part. Bache. Blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. See this, like this. Why is it? This part. Because it has high temperature, it can easily melt the gold and silver part.
I get it, ma'am.
Duhaa, any confusion in this flame part? I think I've completed this. Any confusion in here?
I know, ma'am.
No? Can I move to the next topic, bache?
Yes, ma'am.
So please know the diagram of the flame, very important. Three zones, please mention that zone. Okay. So diagram, you must be very aware of the diagram. It's there in the NCERT. If not, please, if you want, you can note it down. Something like this. Yes. This is the non-luminous zone. Okay. This one is the luminous zone, and this one is the inner zone. See, luminous zone can also be referred to as the yellow zone. And that
Yes,
is very
ma'am.
clear. Why would it be referred to like that? Yeah, he's right.
It's yellow.
Yeah. The yellow color of the luminous zone, that is the inner zone, is the characteristic feature of that zone. Fine. Because it's the
Yes, ma'am.
coal which is unburnt or the carbon particles which is unburnt which is giving that glow. I mentioned this part again just to revise it.
Yes,
Mustafa,
ma'am.
have you joined it? Mustafa, am I audible to you? Please join in. We have almost completed flame. We are moving on to the next topic. Duhaa and Mustafa, both of you, coming on to how to stop combustion of fire.
Ma'am, I joined late because my dad forgot to forward the link.
No worries. Beta, we have completed almost many important topics. Today we have to wrap up this chapter. So please join in here. Okay? How to stop combustion of fire. See, what were the conditions required? Open your notes and please see that we discussed yesterday three important conditions for combustion to take place. A combustible substance or material should be there. Yes. Continuous supply of
Yes, ma'am.
oxygen. Third, the ignition temperature. These are the three conditions. Now, if I remove one of these or two of these, okay, what will happen? Will combustion stop? Yes, that will stop. Clear?
Yes.
So we just have to follow that part. Now, it's very obvious we most of the times cannot remove the combustible material itself. Yes, we just cannot do that. At times we can do that, but then also we need to stop combustion on that material. So what happens? The best way is to actually cut off the supply of oxygen, cut off the supply of oxygen and what's the second, what is it? We can just lower the temperature. How will it help? Lowering temperature will actually decrease, will actually, the ignition temperature of the combustible material would not be there, hence it will not undergo combustion. Yeah.
Yes,
Now,
ma'am.
what are the methods in which we can do this? First of all, water is a water is used as this, clear, as a fire extinguisher. What does water do? What does water do? It
It,
clearly lowers the
it
temperature.
and
Yes, Bache?
yeah.
It lowers the temperature. It's actually best when paper or wood fire is there. Yes.
Yes, ma'am.
But when it's due to electricity or something like that, short circuits, and due to petrol or diesel, water is not a good option. Why? Because first of all, in case of electricity, it conducts electricity. There's no option for that. Yes.
Yes,
And
ma'am.
for petrol and diesel, water will actually settle down, water will form a layer below petrol and diesel. So in no way it will cut the supply of oxygen there. You getting it?
Yes, ma'am.
Example, this is water and this is petrol and diesel. So in no way water is helping it. What's the method for that? What's the method for that, bacha?
We just use carbon. We have to make use fire extinguisher.
Yeah, so basically the concept is we use carbon dioxide. Now, what are the characteristics? Why do we use carbon dioxide? First of all, it's a cooling agent. Okay, it's a cooling agent. So if it's a cooling agent, it will automatically reduce the temperature. Yes.
Yes,
Second,
ma'am.
what is it? When we use carbon dioxide actually helps in cutting the supply of oxygen. How? Let's see. We have petrol and diesel here. Yes. Carbon dioxide will actually form a layer over this. Okay. So here is carbon dioxide. Therefore, it will cut the supply of oxygen or air. Yeah. In both the ways, carbon dioxide is helping to stop combustion or to fire or to stop fire. Any confusion here in this
No,
part?
ma'am.
No, ma'am.
So best is to actually use carbon dioxide. And in what ways can we use carbon dioxide? If we can obviously sprinkle this. What is this? What's the formula? What's the chemical name of this compound? Mhm. Sodium
Sodium
bicarbonate.
bicarbonate.
Baking soda or washing soda? Hmm.
Baking soda.
Very good. Baking. If we sprinkle this, we already have energy there. It will actually decompose into sodium carbonate plus carbon dioxide. Yes. So this carbon dioxide can be utilized for that. But now this is not very helpful if we have, God forbid, large scale fires. So actually, this is good for small scale fires. That's fine. The second reason why carbon dioxide is actually very helpful is that we can store a lot of carbon dioxide, and when it will actually come out, it will expand because it's in the gaseous state. Okay, so it expands. We can store a lot of carbon dioxide in a small container, but when it comes out, it will expand and it will actually cover a lot of area. You getting it? That is because of its
Yes, ma'am.
gaseous property. The third point is that is why we use extinguishers, fire extinguishers. Those are also called as soda fire extinguishers. There are different kinds of extinguishers. Clear, bachcho?
Yes, ma'am.
So all of that has carbon dioxide. Any confusion in this topic? Please feel free to
No,
ask me.
ma'am.
No, ma'am.
Mustafa, I hope it is clear, bache. You joined in late, so
Yes,
hopefully
ma'am.
no problem.
No, ma'am.
Duhaa, any confusion, please feel free to ask.
No, ma'am.
So it's clear why carbon dioxide is used over water at times? Yeah.
Yes,
Yes,
ma'am.
ma'am.
Yeah. Coming on to that next point. What else is left? We quickly have to discuss fuel. Okay. We quickly have to discuss fuel, and then we have to discuss one important thing, that is matchstick. Correct? So I think we will discuss matchstick, and we will discuss matchstick first, and then we will move on to fuel. Is that okay, Bachu, with both of you?
Okay, ma'am.
Actually, tell me, is carbon dioxide stored at high pressure or low pressure? Yes, Bachu. Bachu, we just now discussed this. It can expand very much. So, but how can we store more carbon dioxide in less
At
amount of volume?
under high pressure.
Under high pressure, very good. So basically, carbon dioxide is stored under high pressure, and if it is stored under high pressure, I think you would understand that it liquefies. Yes. Let's assume we have a cylinder of carbon dioxide. Because of high pressure, it will actually be in the liquid state. It will be liquefied in the cylinder. But as soon as it comes out, the pressure is not there. So therefore, it will change to the gaseous state, and that is why it expands. Fine. Now, coming
Yes,
on to
ma'am.
the matchstick. Yes. What do we know about the matchsticks? See, we just need to learn about the composition, the earlier composition and the modern composition of the matchsticks. Okay. What is it? Any idea, bacho? Yes. So earlier, the earliest memory of matchsticks that the humankind has is the pine wood dipped in sulfur. Yes. This is the case of ancient Egypt. Very early. Yeah. This now the modern case. After many years, we had another uh, composition for mastic. And what was that? We had white phosphorus, bache, please understand, white phosphorus. Now remember, white phosphorus is an inflammable substance, okay? White phosphorus plus potassium chlorate plus, this is KClO3, plus potassium chlorate, okay? And what else did we have? Antimony trisulfide. Have you heard of this name, bacho? Trisulfide. So these were the three compounds which are mixed together with some sand particles, okay, or starch. Starch basically was more of a like a glue, okay, and they were pasted on one side of the head, okay, on the head of the mastic. Let's assume this is the mastic. This will be the head of the mastic, and this will have the paste of all these compounds. Is it clear, bacho?
Yes,
Fine.
ma'am.
Yes,
Now,
ma'am.
this was the composition. Now, why was this composition there? So, as soon as we actually rub this head against anything, that will be the friction, that will be the ignition source. That ignition source will be igniting white phosphorus. As soon as white phosphorus gets ignited, because of that, the potassium chlorate, Duhaa, we just now discussed, it will again release some oxygen particles. Yes. Now, when that
Yes, ma'am.
oxygen particles will be released, the antimony trisulfide will actually undergo combustion. Clear? That will be the reason why matchstick actually produces flame or fire. Is it clear with you?
Yes. Yes,
Now,
ma'am.
what was Mustafa? Is it clear to you?
Yes, ma'am.
Okay. So I hope this point is clear too. Potassium chlorate is basically acts as a supply of oxygen, as a supplier of oxygen. It decomposes to give you oxygen. Clear, bache?
Yes, ma'am.
Yes, ma'am.
Fine. Now, coming on to the next point. What was the problem with this kind of matchstick? Since the white phosphorus was present on the matchstick itself, anywhere, even by mistake, if it gets rubbed, okay, that will lead to flame. That will lead to fire. Okay. And that was the reason why many accidental fires were there. You getting it? We have a matchstick like this. By mistake, also, if it gets rubbed, the ignition temperature of white phosphorus is very low. It will actually get ignited and it will lead to the combustion. That was a problem that led to many accidents. Also, second part, it led to a disease in the workers who were working with this phosphorus, who were actually manufacturing these matchsticks using white phosphorus. Okay, and that disease was called as the Fossojo disease. Okay, Fossojo disease. Why did it happen? It occurred because of inhaling toxic fumes of white phosphorus. Clear, bachcho? So these two were the reasons why this kind of matchstick was discontinued. Now, what was the alternative for that? The alternative for that was red phosphorus was used, but where was it used? Let's say we have a box like this, the rubbing surface. The rubbing surface had red phosphorus. Okay. And the matchstick head only had potassium chlorate and antimony trisulfide along with glue and sand particles. Okay. Now, what happened? Now, if this was rubbed against this, friction would be there. Friction would be there. That would ignite the red phosphorus. And red phosphorus has a slightly higher ignition temperature than the white phosphorus. Red phosphorus has a slightly higher ignition temperature than the white phosphorus. So now when this matchstick's head was rubbed against this, and this would only happen if we want to light the matchstick. Yes, this cannot happen by mistake. You getting it? So if this was
Yes, ma'am.
rubbed, the red phosphorus would ignite and that would actually lead to the further reaction of this antimony trisulfide and obviously the decomposition of the potassium chlorate. Clear, bachcho? Now this
Yes,
would
ma'am.
help in one way, that is if even this head gets rubbed somewhere by mistake, that would not lead to the combustion. Okay. Why? Because red phosphorus is not there, white phosphorus is not there, so that would not lead to the ignition of the matchstick. Clear?
Yes, ma'am.
Yes,
Mustafa,
ma'am. Yes, ma'am.
please ask any question if it's there without any hesitation.
Ma'am, do we need to remember like the what exactly
At least you need to remember the composition, bache. It's not very difficult. Just remember that in the earlier one, we had white phosphorus in the matchstick itself. In the modern, this one, the red phosphorus, bache. These are called as the modern day matchsticks. Yes, modern day safety matchsticks.
no, ma'am, do we need to remember like what ignites what?
Yes, that's the basics, bache. Okay, we need to understand that. I know that. And one important point, although that is not discussed in the NCRT, but these matchsticks which had white phosphorus in the matchstick head, okay, these are also called as strike anywhere matchsticks. Okay, strike anywhere matchsticks, because if they strike anywhere, they will actually lead to the ignition. Anywhere matchsticks or the Lucifer matchstick. Yeah, just for the information. Clear, bachcho?
Yes, ma'am.
Any confusion in
Yes.
this?
No,
If
ma'am.
you have your NCRTs, I would actually ask you to go through that. Just for a second, just go through it so that if there's any confusion, you can ask me here. We have one last topic left, so we can quickly cover that up. See, this one. When struck against a rough surface, so that can be anywhere, white phosphorus got ignited due to the heat of friction. This started the combustion of the matchstick. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users. Clear? This we have discussed. The accidental fires and the posage of disease. Coming on to the next point. These days, the head of the safety match contains only antimony trisulfide and potassium chlorate. Yes. The rubbing surface has powdered glass and a little red phosphorus. Powdered glass, yes, powdered glass is also on the rubbing surface so that it helps in the rubbing part to ignite the red phosphorus, which is much less dangerous. When the match is struck against the rubbing surface, some red phosphorus gets converted into white. It simply means it's get ignited. Okay. This is not the correct reason here, but since NCERT is quoting it, we have to go with this. But in simple words, it gets ignited. Clear?
Yes,
This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. Clear, bachcho?
Yes.
Any confusion in this?
No, ma'am.
no, ma'am.
No. Yeah. The last topic, that is fuel. What is a fuel? What is a fuel, bachcha?
It's a substance that is burned to produce energy.
Which is burned to produce energy. Yes. What else? Yes, bachcho. Sorry for the disturbance. So, yes. What's a fuel? What did you answer, bachcha Duhaa? Which is burned to produce energy. Yes.
Yeah, heat
Ma'am,
energy.
it produces heat also.
It produces
Heat
heat.
also.
Fine. So, forms of energy can be many. Good. What else?
It can also produce, in some cases, it can produce light energy.
Light energy. That comes as a byproduct. Fine. What else? Can all the combustible substances be called as a fuel? Anything which is undergoing and producing heat energy, can that be called as a fuel? Yes or no? No.
Yes, ma'am.
A fuel is a type of combustible material or substance which has the following characteristic. It is easily available. Okay, it is easily available. It burns easily. It produces a good amount of heat energy. Then all of that makes it a fuel. Is it clear, Bachchu? Not all. See, in general, we can say fuel is combustible material or substance. In general, a fuel is a combustible material which has these following conditions or properties. Fine. That is a fuel. That is why fuel is specifically used as a source of energy because since it is having good combustion properties, it is burning very nicely, it is producing good amounts of heat energy. That is why it is used as a source of energy. Not all the combustible materials are used as a source of energy. Understand?
Yes, ma'am. I
Fine.
get it.
Yes, ma'am.
Mustafa?
Yes, ma'am.
So what is a fuel? If we can simply define fuel, that is any substance, and by any substance we mean obviously combustible substance because that is only undergoing combustion. Any substance easily available, then burns in air at a moderate rate. See, sodium and potassium, they cannot be considered as fuel. Why? Although they burn very quickly, they produce huge amounts of heat energy. But why can't they be considered as fuel? Yes, Bacho. And any idea, Mustafa and Duhaa?
Ma'am, can you repeat it?
Yes. I'm saying, why can't we consider sodium and potassium as fuels? Because when they are burned in the air, they produce huge amounts of energy. That can be a good source of energy. But have we ever studied sodium and potassium as a fuel? I don't think so. Why?
No, ma'am.
Yeah, but why?
It has to be safe to handle. It
It has to be
should
safe
burn
to handle.
smoothly.
Okay,
Ma'am,
yes.
it's not easily available.
It
It
is
should
very
be
easily
easily
available.
available.
Sodium and potassium, they are easily available. Sorry, Duhaa, you said something which I could not listen to that. Please repeat.
Ma'am, it burns
Rida just
vigorously.
said that they should be.
Exactly. It burns vigorously. Now, one point I've written here, that is burns in air at a moderate rate. You know, we cannot have something as fuel that is not easy to handle, that is out of hands to handle. Yes. So it should burn at a moderate rate. It should provide the energy steadily, but it should not be very vigorous. Clear? Because that might lead to other types of ignition then. Fine. So very important here to
Yes.
note is that burns in air at a moderate rate. Even if it's very slow, that's not a very good source of energy. Yes. But if it's very vigorous, as rightly told by both of you, then it's dangerous. That is not a fuel. Understood?
Yes, ma'am.
And not leaving any residue. That is a fuel. Now, the ideal fuel will have all these qualities, but it's very difficult to find an ideal fuel. So, what are some of the properties of a good fuel? We actually choose the fuel which has most of the properties. Clear example, it should leave less residue. It should give good amounts of energy. Yes. It should be very easily available. It should burn very easily. It should actually have a moderate rate, not like sodium and potassium. Clear? That is burning very vigorously. So all of those
All right.
points actually make a fuel the most usable. Obviously, it cannot be ideal because it will have some residue. It will not produce very huge amounts of energy as needed. Okay, but it can still be utilized because on the basis of points, as what qualities it has near to the ideal fuel. Fine. So I've discussed some of
Yes,
those
ma'am.
properties. Yes. Now coming on to important point, that is calorific value. What is calorific value? Mm-hmm.
Um.
Yes. See, calorific value, just calorific value basically is a measurement of heat energy, a measurement of energy. What is it? Measurement of energy. And just now I told you that fuel is basically used as a source of energy. Yes. Fuel is used as a source of energy. Now, how do I measure how much amount of energy I'm getting from A fuel and from the B fuel? Yes. To measure that, I have a value that is calorific value. So calorific value in simple words is nothing but the measurement of energy released from a burning of a fuel. Is it correct? Understood? Now,
Yes, ma'am.
the standard definition of calorific value is the standard definition. Amount of energy released, okay, when 1 kilogram of fuel. How much fuel we are taking to measure the standard value? 1 kilogram of fuel is burnt in pure oxygen. Okay. Why pure oxygen? Because we are taking that as the reference point. Getting? We are taking that as the reference point. So in pure oxygen, that is refers to as the calorific value. Now the SI units, the SI unit is kilojoules per kilogram. Kilojoule is the amount of energy released. And per how much amount of the fuel? Per kilogram of the fuel. Yeah. So
Okay.
kilojoules per kg is the standard unit of calorific value. Mustafa, is it understood?
Yes, ma'am.
Fine. Now, very important. Basically, if I'm saying this will tell me the efficiency of a fuel. How efficient a fuel is. What is the work of a fuel? To provide the energy to be there as a source of energy. Yes. So what's the calorific value? I will get to know how much energy it is providing to me in the reference point, the standard point, that is 1 kg in pure oxygen. That will tell me the efficiency of the fuel. If it's high calorific value, the efficiency is more. It's a good fuel. If the calorific value is low, then obviously the efficiency is less and the fuel is not a very good fuel. Understood, Bachu?
Yes, ma'am.
Yes, ma'am.
So the fuel which should be taken as almost a good fuel near to ideal fuel, that should also have a higher calorific value. Clear? Now, coming on to quickly the next 2 points, that is, what are the different kinds of fuels? That is on the basis of the state, the solid fuel, the liquid fuel, and the gaseous fuels. Yes, we have all these examples in the NCRT, and we have the different fuels against, we have the values, the calorific values of different fuels against them. So please refer to the NCRT. Please open your NCRT and see that we have the values, the calorific values. Let's say wood. Yes, that is a solid fuel. So it has, I think, around 28,000 or something like that as the this thing. 20,000 around 20 or 22,000, something like that. Okay, kilojoules per kg. That is the calorific value of wood. Coal is one type of a solid fuel. Yes, cow dung. Cow dungs are one type of solid fuel. Gaseous fuel. Can you tell me any gaseous fuel? Yes,
CNG,
Biogas.
CNG. Very good. Biogas. Very good. Very good. So all of these are examples of
LPG,
LPG. LPG is a gas, but it is stored in the what form?
liquid form.
Liquid.
So better consider it in the liquid part. Okay,
Okay.
fine. So all of those are the examples. You can go through that. Clear? Now, last point, bache, regarding this chapter, that is, what are the effects? Achha, what's the best fuel among this? Generally, gaseous fuels are considered to be the best fuel. They're easy to store. They can be stored more in a small place. We just now saw that in case of carbon dioxide, yes, and they can be expanded. So that is one point. They have higher calorific values. Methane, all of those biogas, they have higher calorific values. Okay, they generally leave less residue. Okay, so all these are the reasons why gaseous fuels are considered to be the most important or the best of the fuel. Clear? Now, last point. What are the disadvantages or the side effects of having fuels? What is it? Carbon dioxide, yes. More production of carbon dioxide. That will lead to, can I say, increased greenhouse effect?
Yes, ma'am.
Okay. This will lead to global warming. Global warming, you know, bacho, I hope you know the difference between greenhouse effect and global warming. Fine.
Yes.
What will happen if you need to use wood? Will we actually go for deforestation? That will again go to greenhouse effect and increase greenhouse effect and eventually global warming. Yes. Then when we burn petrol and diesel, all these are liquid fuels. Since they are hydrocarbons, on their burning, what will happen? Sulfur dioxide and nitrogen dioxide will be released. Those are toxic. That will eventually
Yes.
lead to acid rain. Yes. And one last point, very important. The incomplete burning, bache, this we discussed yesterday. The incomplete burning will lead to carbon monoxide, production of carbon monoxide, and that is a toxic gas. Clear, bache? Any problem till here?
No, ma'am.
No, ma'am.
So soot particles, all of that will actually lead to the air pollution. Clear?
Yes,
Soot
ma'am.
particles, that is the unburned carbon particles, that is the result of burning fuel. So the
Yes,
chapter
ma'am.
is completed. If there's any question, please convey that to the team. I'll try to answer those questions. Else the